next our lecture is that proof of mutual information properties. How we can prove in our mutual information properties. First properties is said is a symmetric. Mutual information is a symmetric. How we can define in that? We can define in that in this with the help of this formula. Okay, first is x y is equal to I y x from probability theorem, and joint probability we are using in here. We just saying in equation 1 and we just saying in equation 2, and after that we are combined in a both equation in here. Equation third, what in p x in we just wrote out in like that. Yes, we can wrote out, and I a x y and the summation m n and m I is equal to 1, j is equal to 1, and p x y log 2 p x1 y1 and p I1. We can take in this in formula 4, and how we can in showing you just saying. Yeah, this formula is what is this average mutual information formulas is like that. X and y we just putting in one by one, and here is I is equal to y x y I, and same as that. With the help of both we can prove in those things. With the help of that we can prove in a both thing is a proved symmetric. It's a symmetric. How we can is a solve shoot out in this formulas. I told you in the last lecture that this about in this formulas. Okay, one time we will take a value of x, y and j, and second time we will take the value of x I. So don't be confused in here also. Okay, we just putting in all thing in here. One time in that is the below in this, and this is below in this is the equation number third, and x we need x and y because we want to prove in this. So that okay, so don't be confused in that. And proof, and second our second probability into what is that showing is that non-negative. It is a non-negative. How we can show in that x minus x, same as one time we will take in x, second time we will take in y in here. So don't be confused and taking in one time in x and y, because when we will solve the question, so we will see we have a two equation, one is x, one is y. Otherwise question examiner will be changed the equation a and b. Okay, conditional entropy and mutual entropy, we just taking the formula of conditional entropy, and here we will take in a formula of mutual entropy. Okay, don't be confused in here also. I x y, and in that you just see, you just remember in the formula, and with the help of that formula we will just writing in that formula in the h x y, because we have already solved in this thing. So don't be confused in here also. Like you can see in here in the same thing you just conditional entropy formula. So that's why we are putting in here entropy conditional entropy formula. We can write in here in that to that. इसकी बजाय हम ये लिख सकते हैं, तो हम यहाँ क्या करेंगे, इसकी बजाय हम ये लिखेंगे क्योंकि हमें ये इक्वेशन प्रूव करनी है, और आगे हम सेम चलेंगे. इसकी जगह हमने ये लिख लिया, हमारे पास ये फॉर्मूला था आई एक्स एंड वाई एंड सेम एज इन हियर, और इसकी जगह हम इसको रिप्लेस करेंगे. हम इसकी जगह पे क्या लिख सकते हैं, वी आर रिप्लेसिंग इन हियर टू पी एक्स आई. वी नो ऑलरेडी इन दिस फॉर्मूला ऑल्सो. So we just replace in this in that in here, and after that we just replacing in all things, we just putting pxi in here, and after that in here, after that we will replacing in all things and hx. So again we have already proved in this also in same as it's a non-negative, it's a non-negative. And after that we have already proved in hx, and here is xy. This is also same is like that, we just taking in this in here, and that we just replace this in that in here, and same as that. This is mutual information. Our what is the last proof, it's the second last proof, how we can prove in that. Mutual information is always positive, it's always positive, how we can improve in that then with the help of that. Same as is the formula is x and y, we will take in both, and after that we collab in both in here. Here is x y, here is x and y, same as, and log 2, and after that we have a minus in here, where we have a minus in here, we will write in our minus in outer, before that I, we can, yeah, we can. So again is the same as the formula in here, we can multiply and by that, same as in here, we can replace in that thing, that this. So we can say in a proof is that m summation is x and pk, and we can wrote out in here, in this thing we can wrote out in pk log 2, and this thing we can write in here q and pk greater than is equal to 0. Our minus is outer, that's why it's outer, that's why this the face is like that. When we replace in our minus, so same as in is the proof, like it's a all time positive, we have a negative term, we have a not, so it's all time negative. Mutual information is the last proof. This is all time mutual information related to joint entropy. So we can prove it in here in this thing, x and y, equation 1 and equation 2. One time we will take positive one time we will take a negative form is that, and same as again this is also proved. Entropy, source efficiency, distance, this topic is next topic, we will discuss about in this topic our next lecture.